The following program is brought to you by Caltech.
Let me start today's lecture. And the subject of the lecture is the learning problem. It's an introduction to what learning is. And I will draw your attention to one aspect of this slide, which is this part. That's the logo of the course. And believe it or not, this is not artwork. This is actually a technical figure that will come up in one of the lectures. I'm not going to tell you which one, so you can wait in anticipation until it comes up. But this will actually be a scientific figure that we will talk about. Now, when we move to today's lecture, I am going to talk today about the following. Machine learning is a very broad subject. And I am going to start with one example that captures the essence of machine learning. It's a fun example about movies that everybody watches. And then after that, I'm going to abstract from the learning problem, the practical learning problem, aspects that are common to all learning situations that you are going to face. And in abstracting them, we will have the mathematical formalization of the learning problem. And then we will get our first algorithm for machine learning today. It's a very simple algorithm, but it will fix the idea about what is the role of an algorithm in this case. And we will survey the types of learning so that we know which part we are emphasizing in this course and which parts are nearby. And I will end up with a puzzle, a very interesting puzzle, and it's a puzzle in more ways than one, as you will see. Okay, so let me start with the example. The example of machine learning that I'm going to start with is how a viewer would rate a movie. Okay? Now, that is an interesting problem, and it's interesting for us because we watch movies, very interesting for a company that rents out movies. And indeed, a company, which is Netflix, wanted to improve the in-house system by a mere 10%. Okay? So they make recommendations when you log in. They recommend movies that they think you will like, so they think that you will rate them highly. And they had a system, and they wanted to improve the system. So how much is a 10% improvement in performance worth to the company? It was actually $1 million that was paid out to the first group that actually managed to get the 10% improvement. So you ask yourself, okay, 10% improvement in something like that, why should that be worth $1 million? It's because if the recommendations that the movie company makes are spot on, you will pay more attention to the recommendation. You are likely to rent the movie that they recommend, and they will make lots of money, much more than the $1 million they promised. And this is very typical in machine learning. For example, machine learning has application in financial forecasting. You can imagine that the minutest improvement in financial forecasting can make a lot of money. Okay? So the fact that you can actually push the system to be better using machine learning is a very attractive aspect of the technique in a wide spectrum of applications. Okay, so what did these guys do? They gave the data, and people started working on the problem using different algorithms, until someone managed to get the prize. Now, if you look at the problem of rating a movie, it captures the essence of machine learning, and the essence has three components. If you find these three components in a problem you have in your field, then you know that machine learning is ready as an application tool. What are the three? The first one is that a pattern exists. Okay, if a pattern didn't exist, there would be nothing to look for. So what is the pattern here? There is no question that the way a person rates a movie is related to how they rated other movies, and is also related to how other people rated that movie. We know that much. So there is a pattern to be discovered. However, we cannot really pin it down mathematically. I cannot ask you to write a 17th order polynomial that captures how people rate movies. So the fact that there is a pattern and that we cannot pin it down mathematically is the reason why we are going for machine learning, for learning from data. We couldn't write down the system on our own, so we are going to depend on data in order to be able to find the system. There is a missing component which is very important. If you don't have that, you are out of luck. We have to have data. We are learning from data. So if someone knocks on my door with an interesting machine learning application and they tell me how exciting it is and how great the application would be and how much money they would make, the first question I ask, what data do you have? Okay? If you have data, we are in business. If you don't, you are out of luck. Okay? If you have these three components, you are ready to apply machine learning. Okay. Now, let me give you a solution to the movie rating in order to start getting a feel for it. Okay, so here is a system. Let me start to focus on part of it. Okay? We are going to describe a viewer as a vector of factors, okay? A profile, if you will. Okay? So if you look here, for example, the first one would be comedy content. Okay? Does the movie have a lot of comedy? Okay? For a viewer point of view, does they like comedy? Okay? Here, do they like action? Do they prefer blockbusters or they like sort of fringe movies? And you can go on all the way, even to asking yourself whether you like the lead actor or not. Now, you go to the content of the movie itself, and you get the corresponding part. Does the movie have comedy? Does it have action? Is it a blockbuster? And so on. Now, you compare the two, and you realize that if there is a match, let's say you hate comedy and the movie has a lot of comedy, then the chances are you are not going to like it. Okay? But if there is a match between so many coordinates, and this can be, the number of factors here could be really like 300 factors, okay? Then the chances are you will like the movie, and if there is a mismatch, the chances are you are not going to like the movie. So what you do, you match the movie and the viewer factors, and then you add the contribution of them, and then as a result of that, you get the predicted rating. Okay? Now, this is all good, except for one problem, which is this is really not machine learning. In order to produce this thing, you have to watch the movie and analyze the content. You have to interview the viewer and ask about their taste. And then after that, you combine them and try to get a prediction for the rating. Okay? Now, the idea of machine learning is that you don't have to do any of that. All you do is sit down and sip on your tea while the machine is doing something to come up with this figure on its own. Okay? So let's look at the learning approach. So in the learning approach, we know that the viewer will be a vector of different factors and different components for every factor. So this vector will be different from one viewer to another. Okay? For example, one viewer will have a big blue content here, and one of them will have a small blue content depending on their taste. Okay, and then there is the movie, and the movie will, particularly will have different contents that correspond to those. And the way we said we are computing the rating is by simply taking these and combining them and getting the rating. Okay? Now, what machine learning will do is reverse engineer that process. It starts from the rating and then tries to find out what factors would be consistent with that rating. So think of it this way. You start, let's say, with completely random factors. Okay? So you take these guys, just random numbers from beginning to end, and these guys, random numbers from beginning to end, for every user and every movie. That's your starting point. Obviously, there is no chance in the world that when you get the inner product between these factors that are random, that you will get anything that looks like the rating that actually took place. Right? But what you do is you take a rating that actually happened, and then you start nudging the factors ever so slightly towards that rating. Make the direction of the inner product get closer to the rating. Now, it looks like a hopeless thing. I started with so many factors, they are all random, and I'm trying to make them match a rating. What are the chances? Well, the point is that you are going to do this not for one rating, but for 100 million ratings. And you keep cycling through the 100 million over and over and over. And eventually, lo and behold, you find that the factors now are meaningful in terms of the ratings. And if you get a user, a viewer here, that didn't watch a movie and you get the vector that resulted from that learning process, and you get the movie vector that resulted from that process, and you do the inner product, lo and behold, you get a rating which is actually consistent with how that viewer rates the movie. That's the idea. Okay?